Hello, everyone. We are Team 1, and our topic is Durability Test System for Fluid Couplings. Team members are Dotun, Taylor, Kavi, and Max. We are advised by Dr. Lee and Dr. Hatoum, and we are sponsored by Colder Products Company. We are from the Department of Biomedical Engineering. CPC's connectors are used in pharmaceutical and in liquid and thermal cooling applications. Premature failure leads to increased downtime because of contamination of drugs and damage due to fluids leaking on electronics. CPC's main concern is sideloading. Sideloading occurs when a force is applied at a distance from a fixed axis. This results in a moment arm, which leads to premature failure of connectors. The objective the team was tasked with was designing a test system that can sideload and characterize a variety of connectors. The solution the team came up with has 4 components: the frame, which is made up of extruded aluminum, force application, which is done by the pneumatic cylinder, sensors and hardware, which includes the load cell, differential pressure transducer, and the N9921, which is the data acquisition device all the sensors are hooked up to. And lastly, the user interface, which the team chose LabVIEW. Shown in the video are also 2 open boxes. The box on the top is the wiring for the solenoid and relay required for the pneumatic cylinder. The box on the bottom has all the wiring for the sensors hooked up to the data acquisition device. On to the first component of our system, which is the frame. It is made up of 80-20 extruded aluminum. The pneumatic cylinder, clamp, and electrical system are mounted to the frame, as well as all the pressure regulators. The reason for choosing 80-20 extruded aluminum is because it can easily be adjusted to swap out connectors of different sizes. The second component is force application, which is done by the pneumatic cylinder. It has a 4-inch stroke and a 1/16 inch bore, and it can apply a force from 5 to 200 pounds of force, depending on the desired input pressure. The third component is sensors and hardware. In the top picture is the differential pressure transducer. Its purpose is to measure the difference between the air supplied from our compressed oxygen air tank and then the air leaving the connector. In the bottom picture is the load cell. Its purpose is to measure the force the pneumatic cylinder exerts on the connector. And then lastly, we have our user interface, which shows our connector testing. So the graph on the left is pressure differential versus time, and a spike on this graph indicates a leak. The graph on the right is force versus time, and each spike on this graph corresponds to the number of cycles. This data can then be exported to an Excel file to be analyzed. To conclude, the team built a functional test system that can sideload and characterize a variety of connectors. Ongoing work should look at incorporating temperature and making the system more versatile. Also, purchasing a more precise pressure sensor to detect smaller leaks. And lastly, the ability to control everything through LabVIEW would be ideal, since right now, the air cylinder is controlled through a microcontroller, and the input pressure is controlled through an analog pressure regulator. So we'd like to thank everyone at CPC who made this project possible, as well as all the faculty and staff who helped us along the way.